Okay, so we're going to start this lesson, exercise 14D, ordered selection with identical element. All right, so far, for the previous question that we have done here, we have not permitted any element to be repeated. So like, for example, from the previous question, if we need to order A, B, C, D, E, none of them are repeating. Okay, so we've got all distinct elements, and then obviously if there's no restriction, then the way of number of ways of ordering this is just going to be 5 factorials. All right, so now what we are going to talk about today is what happens if one or two or more elements are repeating themselves, all right, and then how many different arrangements are possible. So for example, like in this case here, if we change that A, B, C, D, E into A, B, C, D, and D, how many number of arrangements are possible when we organize this? All right, so the question is actually pretty easy, okay? The form is actually pretty easy as well. So the actual answer here for that question here is 5 factorial divided by the 2 factorial. Now the question here is, why do we need to divide the number by 2 factorial, okay? Basically, we're over sort of counted by a factor of 2 factorials, okay? Because of that double D here. But then I sort of need to show you the reason. We're just going to start with a very simple, way to sort of visualize what's a reason why we need to divide it by 2 factorials there. All right, so if we just have like A, B, C, D, okay, the way we rearrange this is going to be like A, B, D, C, and we're just going on. Once we have finished that, we can move on to A, C, B, D, A, C, D, B. I'm just going to do one set, okay, it will be enough. And then A, D, C, B, A, D, B, C. All right, so this is just one set, okay? We've got 6 of them. And then obviously we'll have 4 sets of those, all right? Because we can always start with B. Then we can start with C, we can start with D. So in total, we're going to have 4 lots of 6 groups, right? So 1, 2, 3, 4, 5, 6. So that will be like 24 total different arrangements, which is the same as 4 factorial, which is 4 times by 3 times by 2 times by 1. That's 24. Okay, now what I want to do here is have a look at what happens if we making D and C like identical, if we're just changing D to all C's, okay? So like for example, if I just remove that, all of the D disappeared, and all of the D now change into C's. I'm just going to use a different color for the C here. All right. All right. So what happened here is, once we actually change into this form, okay, and then what you can see is, looks like right now, 1, 2, 3, 4, 5, 6, all of those 6 still looks different, okay? But then you need to think about this, all right? When it comes to the questions here, when you start with C and D's, this becomes a different story, okay? So, for example, if we start from C, we can have something like, let's just do this, all right? So just to give you one example here, we can have something like, C, A, B, D, and then we can have C, B, A, D, and it keeps going, right? Then for this one, for the second one here, we can have D, A, B, C, D, B, A, C. But then remember this, if we replace all the D's by C's, all right, and we replace all the D's by C's, let's see what happens. Okay, if we replace all the D's by C's, as you can see here, these two groups are identical to each other. There is no difference anymore. All right, so the groups are identical to each other. All right, so therefore, it's just a way, like we if we have identical elements, in that case we're gonna counter these two elements, all right, by a factor of 2 factorial, because this time both C and D can consider to be the same thing, all right, because previously, previously D and E are different, so we can rearrange them in any direction, or in any position here. But then for D and for these two letters to be the same now, these two D's can be interchanged without changing the words. All right. Okay, so there's a formula that you need to know. So suppose that we have a word like suppose that we have a word of n letters, like the previous one will have 5 letters. And then we have, within these n letters, we'll have R1 alike of one type. Okay, then we can also have a, R2 alike of, of another type. All right, and then we can have more, okay? And remember, we can have more than one letter to repeating themselves, all right? So therefore, the number of ways to rearrange the letter here, all right, is given by this formula. So number of arrangements all right, number of arrangements is n factorial divided by r1 factorial times by r2 factorial times by r3 factorial times by ... until you get a rk factorial. All right, so this is the formula. So a very simple example is if we have like, A, B, 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 C, 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 C. All right, and the question asks you the number of arrangements. In this case here, all we have to do is first we count the number of elements there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got all 10 of them. All right, now if all these 10 of these letters are distinct, so like they're all just A, B, C, D, E, F, G, then it will be just 10 factorials. However, this time we'll have two lots of A's. So according to this formula here, 2 lots of A's we need to divide by 2 factorials. Then we'll have 2 lots of B's, so we need to divide by 3 factorials. And we'll have 5 lots of C's, so then we need to divide by 5 factorials. And that is the way to do the calculation. It's actually pretty easy. Okay, so that's all you have to do. All right, you just need to count how many letters that was repeating, and then we divide it by the according numbers of letters there. If there are more than one letter that's repeating, then all you have to do is just count and then multiply the numbers for the denominator. That's what we have to do. But please, be careful. There will be also, like, we're gonna also talk about restriction as well. So when the restriction kicks in, what we need to do is we need to deal with the restriction, and then we need to divide it by the number of elements that's repeating. All right, so we're going to try a few questions from the exercise. All right, so what we're going to do is have a look at question. I'll just write down example 1. But this is actually from question 8 of the exercise. All right, so now the question here is 8A. We've got the word sloop, S-L-O-O-P-S. Okay. If there is no restriction, all right, find out how many arrangements there. Okay, if there's no restriction that applies to the questions here. All right, so the number of arrangements here, if there's no restriction, is we just need to count 1, 2, 3, 4, 5, 6. There's 6 letters in total. Okay, so that would be just 6 factorials. However, you've got 2 S's, okay, so therefore you need to divide by 2 factorial. And in the meantime, you also have 2 O's, all right, so you need to divide by another 2 factorials. And that's how you do the questions here. You can use your calculator, obviously, to work out the answer there. All right, what about it if we have some restrictions, all right? What about, if there's some restrictions there, so the 2 O's must be staying together. All right. Okay, so this becomes a bit tricky this time. If 2 O's must be staying together, all right? So let me just draw some diagrams. So these 2 O's must be as a group, okay? And then for the rest of the letters, it doesn't matter with the position. All right, so what does that mean is you have to deal with the question with really careful, consideration here, because otherwise you'll probably make a mistake by dividing an extra 2 factorials. So we first write down how many groups we have, okay? All right, and we do this. Okay, so now if you look at this, I've got 1, 2, 3, 4, 5 groups, all right, because double O's are staying together. So we've got like 1, 2, 3, 4, 5 groups. So in that case, we can just write down that's 5 factorials, okay, which means that double O here can be anywhere inside. Once we have finished that, we need to divide it by 2 factorials, okay, just because we've got double S here within these groups. Now, do we need to divide it by another 2 factorial? So it's like, do we need to times by 2 factorial on the denominator? You don't, okay? The reason is because you have already make sure that these two O's are actually staying together. All right, they're not going to be separated in this, in any position there. Okay, so you don't need to divide it by 2 factorial. In the meantime, you don't need to times by 2 factorial either, because again they're identical to each other. All right, so therefore even you switch these two around, it's not going to make any difference between the arrangements. So therefore the answer will be just 5 factorial divided by 2 factorials. Just have to be very careful with question like this. All right, so question C is if the two O's are to be separated. All right, so in order for us to do this question, if you try to do this question by analyzing the number of ways where the O's are separated, then it's going to take a while to do it. The quickest way to do question here is to work out the total arrangement when there is no restrictions, all right, which is this number here, and then we'll work out the number, the number of arrangement when the two O's are actually staying together, all right. So we can just using the total minus when they're actually staying together, all right, and then we can use our calculator to find out how many arrangements are possible here. Okay. All right, so yeah, that's how you do it. That's the easiest way to do it, all right, because there is no other, situation where you can place the O's. It's either they are staying together or they are separated by other letters. All right, so that's the easiest way to do it. All right, part D. What about if the O's are together and the S's are together? All right, so we're going to make sure that both O's and S's are actually staying together. So this is very similar to part B. All right, so we've got O and O joined together, S and S and joined together, and then we just do the remaining of them, L and P. So that's 1 and 2. All right, so in that case here, we're grouping them as like 1, 2, 3, 4, 4 groups, instead of 6 groups here. All right, so if we have 4 groups, then the arrangement is just equals to 4 factorials. Now, do we need to divide it by 2 factorials in this case here? You don't, because we are actually grouping these O and O together, so you don't need to, divide it by 2 factorials and 2 factorials anymore. They are already in the group. You don't times by 2 factorials and times by 2 factorials either, because of these two letters are the same. All right, they're exactly the same. Okay, so again, the type of question are very similar to the one that we did before, but just, we have an extra something like you need to be very careful about, which is you have to count. If there's any letters that's, repeating themselves, you have to divide it by the number of letters. Apart from that, the rest of them should be okay. All right, we'll probably just do one more question. It's going to be a short lesson today. It's not going to be that really long. Seems this is pretty much very easy. If they just remember if there's an identical item, so you divide it by the number of times. All right, so have a look at this question, which is question 10. Question 10 tells you how many ways, that's not how you write W. All right, in how many ways can the letter of the word, all right, I'll just write the word here. All right, proportionality, okay, it's a pretty long word. All right, be arranged so the vowels and the consonant occupy the same place. Okay, so can be arranged so that the vowels and that's not the right spelling. Consonant SONATS. Okay, ANTS. It's incorrect spelling again. Still occupy the same place. All right. How would you do this question? What does that mean? All right, so we need to rearrange these words here. All right, and then the question says the vowels and consonant has to occupy the same places. So for example, the first letter here still has to be in a consonant, like in this has to be in a vowel, this has to be in a vowel. You can't change the position of the vowels and the consonant in different positions there. Okay, but you can actually change the, for example, the first one, you can have a P, but you can also have, instead of P, you can also have an R here because they're both, consonant. I think that's the idea of the question. Okay, that's what we're actually supposed to do. So in this case here, okay, so I think the best way to do this question is to, maybe we'll drop boxes. Okay, so we just find out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. There are 15 letters. Okay, so well, okay, that's 15 letters. All right, it's a pretty long letter here. All right, so what we need to do here is I need to think about this. I'm thinking about, like, for this position here, we still need to have the P or R. You can also have R here. So we just need to find out how many consonants and how many vowels are together. All right, let's try this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 consonants. Then we have 1, 2, 3, 4, 5, 6. So we have 6 vowels. All right, I'm just doing this one to check if it's correct for the number of letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. Now, if there's no restriction, it will be very, very easy to do, okay? If there's no restriction, it will be just like 15 factorial divided by the number of, element that's repeating themselves. But then because of we have arrangements here, let's just count how many letters we have. We have 2 I's, we've got 3 O's, 2 P's, 2 R's, 2 T's. Okay, all right. Okay, all right, that's an interesting question. Okay, let me just write down all the position where we can put the consonant and vowels, okay? There should be an A here, so I. Yep, that's right. Okay, so 1, 2, 3, 4, 5, 6. All right, so have a look at this, right? We've got 6 positions to be the vowels, right? Now, we need to make sure the vowels are still in the same position, but within this position here, we can rearrange them. So in that case, what we need to do is we need to separate the vowels and the consonant. All right, we can't really join the vowels and the consonant together. We'll have to separate it and talk about it. So therefore, for vowels, we've got 6 of them, all right, so therefore that's going to be 6 factorials. However, we still need to divide it by, we've got 1, 2, 3 lots of O's, so we divide it by 3 factorials, and then 2 lots of I's, and divided by 2 factorials. Okay, so that's just for the vowels, right? That's the arrangement for vowels, when the vowels is not changing the position. Now, the rest of them is just going to be the consonant, right? Which is going to be P, R, then we can have, I think I just need to move these 2 letters across. Yep, it's not going to change the answer. All right, the answer is still right. Okay, so now we've got 9 consonants in this position there. All right, now within the consonant, they have to be in this exactly the same position. However, within the consonant, you can change them. You can switch the T and L over. You can put a T here. So in that case, for consonant, All right, it's just going to be 9 factorial in total, and it would divide it by, for consonants, we'll have 2 lots of P's, so divided by 2 factorials, 2 lots of R's, so that's another 2 factorials, and 2 lots of T's, that's another 2 factorials. Once we have finished this, all right, we multiply these two together to find out the final answer, and that should be the answer to the question. All right, so it's a pretty interesting question here where they're talking about the position of the consonants and the vowels has to be stay the same, and then we need to talk about this one into 2 different cases. Otherwise, we can't really do this question. I was thinking previously. I was thinking about using the counting methods. I was thinking about at this position here, how many consonant I can have. That will be 9, and that will be 8, that will be 7. That will be eventually becomes 9 factorial, and then you divide it by the number of elements that's repeating. Okay, all right. Yeah, please definitely try this exercise. It's a very interesting exercise with quite a few different interesting restrictions. But keep in mind, whenever now, starting from now, for the later question, for the future question, if you see there's a common element in the words, you need to divide it by the number of times that common element appears. All right, thank you.